this is Calculus 12, Chapter 3.6. We're going to be learning the chain rule and its use for composite functions. And this is a quick intro to composite functions. And composite functions are where we take the output of one function and use it as an input to another function. And this can happen multiple times. A common use is in business. So suppose we have X equals cost of some product P. Then Y is the distribution price of that cost. Z is the wholesale price of that distribution price. Then U becomes the retail price of the wholesale price. Then we add tax on top. And we could write this as a composition. T of R of W of D of C of P. Okay? So in bed mass, we do what's in the brackets first. So this is the first thing we do, then the next thing we do, then the next thing, just like we did down here.
This is important.
So this is the chain rule for compositions. So if we're taking the derivative of f of g of x, we do f prime of g of x times g prime of x. Okay, this is not obvious. The other way to look at it, we take the derivative of f with respect to g, then we take the derivative of g with respect to x. However, it's easier to view it like this. Once you get used to it, then you can look at it like this. So let's take a look at an easy example to start off with. G is our inner function, f is our outer function. Okay, so we have x cubed as g and x to the power of 5 as f. And to use the chain rule, we're going to do derivative of f. So that's 5. And then we put g in, x cubed to the power of 4. And now we do d dx of x cubed. This is 5, x to the power of 12. When we have powers of powers, we multiply the exponents. The derivative of x cubed is 3x squared. Now we can simplify. This is 15, x to the power of 14. When we are multiplying powers, we add the exponents. Okay, and this part is the chain rule. And we always use polynomials because it's easy to show why it's true with polynomials. So let's take a look at the easy way of doing this. We could have just done f of x equals x to the power of 15. Using the power rule, this is 15 x to the power of 14, which matches what we did here. And just a reminder, for this, x cubed prime, we're not allowed to do this, not allowed. Okay, you have to write g of x equals x cubed, g prime of x equals 3x squared. Okay, let's let this be u and this be v. So our chain rule says f prime of x equals u prime vx times v prime x. Okay, we don't always have to use f and g. We could use different letters. Using u and v is convenient when you have f. In our previous example, we used f twice. This f is different from this f, so you have to keep that straight. Okay, there's nothing to simplify first, so we have to use the chain rule. So f prime of x equals u prime, so that's cosine, and we put in v of x. We don't want to take the derivative here. It's not as simple as not u prime of v prime, okay? That's not the chain rule, not. The chain rule is a little bit more complicated. Okay, and then we do d dx of x cubed. And this equals cos x cubed times 3x squared. And remember, we want to order this expression properly. Polynomials come first, 3x squared cos x cubed. And the reason is we don't want to be multiplying these two together. That would be incorrect. Okay, we're going to look at the power chain rule. That's when we have g of x to the power of n. So the derivative is f prime of x equals n times g of x to the power of n minus 1 times g prime of x. Okay, we did this last time, so we should know the answer. F prime of x equals, we take the exponent out front, and we put in g of x, that's just sine x. We reduce the power by 1, that's just so it's 1. And now we do the derivative of g, which is sine x. Okay, and then we get 2 sine x cos x. And when we're ordering, remember sine comes first, cosine comes next, and tangent comes last. And just so that you can recall what we did last time, we did the product rule. This is sine x cos x plus cos x sine x. And we have 2 sine x cos x. Product rule. Okay, here's a harder example. F prime of x equals, so we're doing the derivative of the outer one. Cosine, we just copy the inner function, sine x squared. And now we need to take the derivative of the inside, d dx sine x squared. This is done. There's no more derivatives, just copy this part. The only part that we're changing is where we have d dx. Okay, we're doing the derivative of sine, so that's cos. And we copy the inner one, x squared. Now we do d dx of x squared. Now we have cos. Again, these are all done. Just copy it. And then we have 2x. And now we need to order it properly. So we put 2x cos sine x squared cos x squared. Chain rule looks like it's a lot of work, but a lot of it is just copying. So we copy, 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 copy. So all you're doing is concentrating on doing the last part, which is taking the derivative of one thing. And you have to see your compositions. So this is a function, this is a function, this is a function. You have 3 functions. And if you wanted to view this in Leibniz notation, we have f of x equals sine g of x. G of x equals sine h of x. And h of x equals x squared. And what we're doing is df, d g, dg, dh, dh, dx. Okay, these do not cancel out. This means taking the derivative with respect to, so we don't cancel them. Okay, another way to view the chain rule. I'm showing you different ways so that you can see what we're trying to do, and maybe one way works easier for you than another way. So we let u equal x to the power of 4. So du dx equals 4x cubed. Now y equals cos u. And dy du equals negative sine u. Okay, so just take the derivatives of simple functions, and now we can combine it. Minus sine u, x to the power of 4. So when we're substituting, we shouldn't have our temporary variable anymore in our final answer. And then we put in 4x cubed. And again, we want to order the polynomial, negative 4x cubed sine x to the power of 4. And again, the du's don't cancel. Now, why do we want to work in radians instead of degrees? Okay, when we're doing the derivative of the trig functions that we did last time, it's all in radians. So if we're in degrees, we have to convert it to radians, and we get this formula. If we take the derivative, we have to do cosine, and then we have to do the derivative of the inside, this. So we get this as the first derivative. If we want to take the second derivative, we move this out front, and then we take the derivative of cosine, we keep the inside, and then we do the derivative of the inside again. So it gets messy fast. Whereas in radians, we had cosine as the first derivative, second derivative is negative sine, and then we would have negative cosine, and then back to sine. So very simple. Okay, here's another way to ask a question. Find the derivative of the composition f of g of x, where you have f of u equals 1 minus 1 over u, and g of x equals 1 over 1 minus x. Okay, so the derivative here, f prime of u equals 1, that's a constant that goes away, and 1 over u. So it's best to write this as f of u equals 1 minus u to the negative 1. So now we use the power rule on this. We get a negative 1, and then we decrease the exponent by 1. These two negatives cancel out, so we just have u to the negative 2, or you can write this as 1 over u squared. And the derivative here, g prime of x. Again, we might want to rewrite this. We have g of x equals 1 minus x to the power of negative 1. This is going to require the chain rule. So we're going to use the power chain rule. So negative 1, 1 minus x to the negative 2, and then we need ddx of 1 minus x. And this is going to give us negative 1. That's going to cancel out with this negative 1. So we have just this left over. So it's 1 over 1 minus x squared. Okay, putting it all together, we have f of g prime of x. This is not an expression, so it's okay to do the derivative sign there. So we need to substitute. We need this. So 1 over. We're substituting g of x for u. So we have 1 minus x squared. And now we put in the derivative here. So 1 over 1 minus x squared. And since this is a fraction, we're going to multiply by the reciprocal. So this is 1 minus x squared over 1 minus x squared. And we get an answer of 1. Okay, that's a lot of work to get the answer of 1. And because this is 1, it implies that the slope is 1, which means these functions are inverses of each other. And we can check. F of g of x equals x. So if f of g of x equals x, then the derivative is 1. So f of g of x equals 1 minus 1 over 1 over 1 minus x. Okay, this is a fraction. You flip it over. So 1 minus x, and that equals x. So it's true. Okay, let's look at another problem. So we have the same thing. We have two different functions. F of u equals u plus 1 over cos squared u, and we have g of x equals pi x. It's best to rewrite this. U plus cos u to the power of negative 2. And we're going to evaluate this at x equals 1/4. So f prime of u equals 1 plus. So we're going to use the power chain rule. This is negative 2. And then we have cos u to the power of negative 3, because we need to decrease the exponent by 1. Now we need the derivative of this, and that's sine u. That's negative sine u. And then let's simplify this. 1. There's two negative signs, so that's just plus 2. And sine comes before cosine, so sine u cos u to the power of negative 3. Okay, let's do the derivative here. G prime of x equals pi. This is a constant, this is not a variable, so that's our derivative. Now we put it all together. F of g prime of x equals. So remember, we got to substitute g of x every time we see a u. So we have 1 plus 2 sine pi x cos pi x to the power of negative 3. And now we need to add the derivative of g, which is pi. And we're going to rewrite this to pi 1 plus 2 sine pi x over cos cube pi x. Now we're going to substitute our value of x, f of g prime 1/4. That equals pi 1 plus 2. Sine pi over 4 is 1 over root 2. And then we're going to have 1 over root 2 cubed. And we get pi 1 plus. So this is going to be root 2. And then we're going to multiply by the reciprocal, which is root 2 cubed. So root 2 to the power 4 is going to be 4. So we have 5 pi. And that completes this lesson.